Hello, everyone. My name is Jeff Lafrenz, and I'm the president and co-founder of Vizworx. Today, I will talk about two industrial use cases for immersive reality technologies. The first will be on rethinking traditional control rooms, and the second will be on a new approach to the design of industrial infrastructure. To start off with, delivering enterprise digital experiences, Vizworx is an advanced software solutions company leveraging the latest in augmented reality, virtual reality, artificial intelligence, web, mobile, and complex data visualization technologies and techniques. Vizworx supports a number of industries that includes energy, construction, agriculture, government, defense, and aerospace. We enable the human in the loop to fully engage, more deeply understand, and significantly enhance their decision-making capabilities. As I mentioned, I'm going to dive into two different examples of industrial virtualization work that we are doing. The first of these is virtualizing of traditional control rooms. And when we speak about traditional control rooms, there are three primary characteristics that I want to emphasize. First and foremost, not only do control rooms manage critical infrastructure, but they are also critical infrastructure themselves. And to address this, most primary control rooms have a geographically distanced backup control room in case of failure or lack of access to the primary. Cybersecurity concerns are also extremely important, which is why most control rooms pre-COVID had limited to no remote access capabilities. COVID, of course, changed a great many things, including the recognition of the need, acceptance, and technology to enable secured remote access. And while control rooms have a common purpose, the infrastructure they manage differs greatly, even within the same industry. This is reflected in the variety of physical layouts that one sees. Except in very unique circumstances, no two control rooms are alike. And therefore, a tremendous amount of effort and cost goes into the design and build of each control room to meet specific operational needs. Such a fit-for-purpose approach generally works well. However, it does limit the ability of individual operators to adjust their work environment to meet changing operational conditions, or even their own personal preferences, and limits the capability of the entire facility to adjust to new operational requirements, such as providing enhanced situational awareness under emergency conditions. Of course, to convey the large volume of visual information required in a control room, there are a large number of 2D screens used, in addition to all of the other physical infrastructure. And therefore, from a financial perspective, this represents a significant investment for the initial deployment, ongoing maintenance, and technology refreshes over time. In the US utility market, we are seeing increased scrutiny around these expenses, particularly during technology refreshes. And one interesting consequence is that it is getting harder and harder to justify the significant cost of large overview displays, even though they have niche operational benefits, as for the most part, they seem to be more valuable for public relations than operations. In partnership with the Alberta Electrical Systems Operator, or AESO, a research project was started a number of years ago at the University of Calgary to explore what next generation control room technologies might look like. This included everything from blending in new data sources that were not typically available, such as social media, at least at the time, to new ways to analyze and explore operational data, to new ways of presenting the resulting information to increase comprehension and reduce cognitive loading. Building on this base, Vizworx has developed the Virtual Operations Environment, or VOE, framework. And like a traditional control room technology, VOE is built around the recognition that no two control rooms are alike, and therefore solutions need to be flexible and customizable to meet specific operational requirements. Unlike traditional control room technologies, VOE doesn't require any 2D screens. Instead, it leverages the rapid advancements in augmented and virtual reality technologies to provide virtual control room environments that can not only meet the capabilities of a physical control room, but exceed it in many ways. In order to keep critical infrastructure operational under pandemic conditions, various extreme measures were required. Lacking sophisticated remote engagement capabilities, the safest approach was generally to move all control room operators into isolation from family, friends, and even other control room shifts. And while this was effective in the short term, the emotional and physical toll on both operators and their families limits this as a long-term approach. While secure remote access capabilities have been available in other sectors for a long time, pre-COVID, they were not widely accepted for control rooms, except in certain niche cases. However, like many sectors, COVID pushed the advancement of digital solutions in the control room market, including the acceptance and adoption of very secure remote access technologies. Now, while this has opened the opportunity for control room operators to engage from a variety of locations, including their homes, the need for a large number of 2D screens to enable full engagement still limits the true operational benefits of remote engagement. Now, on the other hand, a virtual reality-based control room environment, such as VOE, has effectively no limitations when it comes to the amount of visual information that it can present. Therefore, a control room operator connecting from home through virtual reality can easily bring up as many quote-unquote screens as they need to in order to understand and manage their control room tasks. And they also, of course, require a much smaller physical footprint to do so. Now, one of the challenges, of course, is the amount of visual information that can be presented to an operator in a control room is generally limited by the number and size of physical screens available, as well as the operator's ability to work with those screens. Now, while much has been done to optimize visual presentations and to adjust them based on different operational conditions, there is an inherent limitation to fully physical environments. As an example, should weather be a useful but non-critical data source, an operator will be forced to choose between either occupying some of that valuable physical monitor space with a weather feed, or using a set of controls to bring up weather information whenever they want to see it. In comparison, a virtual control room has no limitations when it comes to the virtual space into which control room information can be placed. Using VOE, for example, operators can customize their virtual space, placing information anywhere in the 3D environment around them, and can easily switch between different layouts as operational needs change. Using the weather example again, the operator could place a weather feed off to the side or even at their feet, and a simple glance in that direction will immediately update them without needing it to occupy more prime visual space or requiring them to do any particular complicated set of controls to access it. The running of drills is critical to ensuring the timely and appropriate response to a variety of scenarios, typically ones with significant operational consequences, such as a cyber attack. Such drills are frequently paper-based tabletop exercises, and while relatively easy to run and of low cost, they typically provide only a superficial understanding of both the scenario and the appropriate responses. As such, in many cases, they become checkbox exercises that meet a regulatory requirement, but don't provide any true operational benefits. Simulation software does exist, of course, for running drills. However, such systems are typically run in isolation from the operational environment, often as a web or desktop interface. While better in some ways than paper-based exercises, their isolation from the real operational environment means that their actual operational benefits are still somewhat limited. In a fully virtual control room, such as VOE, the operational environment and the drill environment can actually be identical, differing only in the source of the data that drives them. Virtual control rooms are therefore ideally suited to simulation-based drill exercises, providing a low-cost, realistic environment that showcases true operational capabilities. Virtual reality-based training is proven to be very effective in accelerating the speed to proficiency. As an experiential training environment, it can often meet or exceed the capabilities of a physical training environment, and at a lower cost and much higher flexibility. Amongst its numerous benefits, the latest virtual reality hardware also supports eye tracking, which can be used to more rapidly train operators on not only what to do under various operational conditions, but also how and where to find the information needed for their decisions. Virtual reality training can be used as an enhancement to physical training environments, allowing trainees to gain hands-on experience with a virtual version of the physical environment when access to the physical environment is limited or unavailable. It can be used to create rare instant training scenarios that would be difficult or perhaps even dangerous in a physical training environment. And in the case of VOE, which is fully virtual, it can replace a physical training environment altogether. Now, one example of the way that VOE is being used is our partnership with MDA, a large Canadian space and defense company, and Simon Fraser University. Together, we are building a system that takes in a large variety of data feeds from satellites, aerial sensors, terrestrial sensors, social media, and others, extracts information about ships and their movements, analyzes those movements to detect illegal fishing activities, and presents the resulting information to the appropriate operator to stop such activity. This solution blends together extensive artificial intelligence analysis with the advanced visualization capabilities of VOE. And on the following few slides, I will show you some examples of the visualization interfaces we have built to support this use case. Now I'm going to qualify the next few slides by noting that I'm showing you a virtual reality environment through the lens of a 2D display. So this doesn't really provide the true experiential impact of virtual reality to you. However, it will give you some sense as to what can be done in virtual reality that completely changes how we engage with data. So operationally, there is typically way more data than any single operator can handle. Therefore, the first requirement for the operator is to narrow down the data set to reflect only their area and time of interest. We, in this particular case, provide a number of options that are available to do so, including, of course, the geographic region, the starting date, and the date range they want to work with. But you'll notice that the interface that we're using here is, although it's 2D data in some sense, is represented in a 3D environment. And of course, a very common type of display is a standard map interface, which would be the virtual equivalent of a large tabletop display, such as a war room table. This allows the operator to get a high-level perspective on locations of ships in the region, and much better as a result understanding the overall situational environment. The wall map interface replicates the capabilities of a standard overview display. The operator can place it anywhere they want as a broader overview of the region of interest. And they can have any number of these displays showing different areas of interest. The true benefits of using a 3D visualization environment become clearer when time is used as a third dimension. On a 2D display, a ship track showing fishing activities, for instance, may show up as just a bunch of lines overlaid on top of each other, making it very difficult for the operator to get any sense of the relative times between tracks. However, when shown in 3D, the tracks immediately become obvious and separate, allowing the operator to easily identify fishing activities. Another place where this can be used is where you're trying to identify places where two ships are actually doing a transfer at sea. This transfer could be, of course, fish from a fishing vessel that was caught and is being transferred to a factory vessel, or it could be an illegal transfer of goods between two vessels that perhaps are involved in smuggling. Again, showing this on a 2D display, it's not easily obvious to see whether those two ships crossed at the same time in the same location, or whether they just happen to be going through the same place at different times. However, showing this in 3D, where time is in the third dimension, you can easily see whether those ships came close to each other and stayed close to each other for a duration of time. Once a ship is identified as of interest to the operator, either because of its location or its activities, the operator can then pull up detailed information about the ship from a variety of sources. With this information available, the operator can then make the determination as to whether the ship has been seen previously, whether it has a history of illegal activities, and whether it should be tagged for interdiction by Coast Guard ships or planes. This display, although again we're showing this in 2D, actually wraps around you in 3D, so you get a much more immersive experience when you see this in virtual reality. The operator can link one or more displays together to keep the areas of interest in the linked displays consistent. This also ensures that the operator is easily able to compare and correlate information in different displays, increasing comprehension and reducing interpretation errors. Finally, I'll show you the area that we will kind of what we call collaboration. So you can imagine that an operator working in this environment has a specific operational need for the kind of information they're looking at. But they also occasionally have the need to share this information with other people to get other perspectives and opinions on this. This collaboration mode enables them to share a particular operational mode that they set up with other people, other operators. And these operators can be located anywhere. So they don't have to be in the physical location where the person doing the collaboration initiated is. They could be anywhere in the world as long as they have good internet access. So that enables them to both look at and talk about the information and collaboratively discuss and determine action plans that come out of this. So that was the virtual operations environment. And so the second example I'll give you in this space is a partnership we're doing right now with Mechdyne in the US. So they're a large systems engineering organization, and together we're pursuing the market for our VOE technology with electrical utility operators in the United States. There's very strong interest within this market to explore new ways of presenting and engaging with control information, particularly as extreme weather conditions create operational challenges for traditional control environments. However, given the critical nature of this infrastructure and the need to fully assess the operational impacts around the introduction of new technologies, initial opportunities in this market are focused on non-operationally critical areas. This includes the creation of advanced training environments, the running of more effective operational drills, and the creation of improved situational awareness capabilities under emergency conditions. The final VOE example I'll talk about briefly is our recent discussions with NATO about the creation of a space domain awareness solution that leverages VOE. Nearer space, of course, has gotten very crowded with active satellites, inactive satellites, spent rocket boosters, and various debris. A recent incident earlier this year saw an old Russian rocket booster collide with an operational Chinese military satellite, destroying them both and creating a cloud of debris that's now an additional risk for other satellites in the low Earth orbit. NATO wants to better understand this near Earth space environment in order to make better operational and tactical decisions that rely upon space-based assets, such as communication or sensor platforms. So that was the overall virtual operations environment. I'm now going to go on to the second example, that of virtualizing infrastructure design for large capital projects. Based on current research, a typical infrastructure or construction project has between 5% and up to 30% of construction costs related to rework. And although some of this is related to operational issues during construction, much of this can be traced back to issues with the design that were not noticed until construction was underway. Vizworx has worked with a number of engineering companies, owner-operators, and construction companies to leverage the latest in augmented and virtual reality technologies to address this problem through the development of collaboration tools that significantly improve the process of designing infrastructure. The technology developed is called Panoptica, and the commercial purpose is we've spun this technology into a subsidiary that we call InsureWorks. There are a number of places within the overall lifecycle facility where the use of augmented and virtual reality are making traction. Pre-construction, this includes early and ongoing stakeholder engagement, as well as design and design reviews. During construction, this includes both on-site and off-site visualizations of construction progress and construction aids. And post-construction, this includes facility operations and management, as well, of course, as training for staff. As virtual reality or VR has been around longer in a commercial sense than augmented reality or AR, You will notice that in general, VR has been more broadly deployed than AR, sorry. On the following slides, the green bar indicates AR deployment across the industry, while the blue bar represents VR deployment. A ranking of 3 indicates it has reached the stage of basic implementation, with a 1 meaning it's not used at all, and a 5 indicating it's fully implemented. Of course, actual deployment will vary from company to company, so this can also be viewed as an industry acceptance level for these different technologies. Stakeholder engagement is actually the most widely accepted use case for AR and VR. And even though there is still only barely achieving basic implementation, as you can see. Our own experience in developing solutions in this space has shown the significant value to our clients and their stakeholders, so the business case is clear. However, there's still a lot of room for further development and deployment of solutions to support the use case of AR and VR more broadly. AR and VR are also making inroads in the design space. We're seeing a number of design tools with integrated VR and AR capabilities. And this enables designers to get a better spatial understanding of their design decisions. As integrated tools, they typically allow the designer to make design decisions and quickly see the impact on spatial orientation and spatial relationships using AR or VR. At this point, they enhance the existing design tools and are not a replacement for those design tools. But one could see the opportunity in the future to create a fully AR or VR-based design environment. As this area is the primary focus of the Panoptica technology that we have developed, we have direct experience the significant benefits that can bring to our clients. By enabling both task-based and ad hoc, synchronous and asynchronous, remote and local design reviews, our clients have been able to identify and address millions of dollars worth of design issues that classical design review processes were missing. Key to the benefits is the ability to better engage experts in the review process and truly get the value from their experience and knowledge. There are a number of potential use cases of AR and VR in the overall construction process that includes construction planning, progress monitoring, construction safety, and operational support. The potential benefits are very large, but the rate of adoption is still fairly low. There are, of course, many exceptions to this, and it has been changing significantly in the past few years. But statistically, the construction industry is one of the lowest adopters of digital technologies. In the end, there will be tremendous opportunity to support AR and VR solutions for construction support in the coming years. Augmented and virtual reality are also being used in operations and management. And particularly, this is around the idea of providing timely and useful information to on-site workers and to office workers about what's going on in their operational facilities. This has many different operational benefits, but this is still at a very early stage in terms of actual deployment. And part of the limitation for this has come because of the limitations of the technologies themselves. One of the requirements, if you really want to provide fully operational, useful information to site workers, as an example, is creating spatial anchor environments that enable them to actually locate relevant digital information in the physical space that can be viewed through an augmented reality device, as an example. AR and VR has been making significant progress as a technology for training purposes, as we previously talked about, and in a number of industries. In comparison to paper-based training, it has shown significantly increased both the understanding and the retention of training material. However, the adoption of this technology for training differs greatly between industries, and in construction and facility operations, it is still at a relatively early stage. The proven benefits are significant, and we expect adoption to accelerate over the next few years. As we have built and deployed Panoptica, an augmented and virtual reality-based technology in support of design reviews, there are a number of key insights that I wanted to share with you regarding what we have seen happening with this technology in the industry. To recap, Panoptica is a task-based collaboration tool that enables both synchronous and asynchronous review of infrastructure designs, both in a remote and local capability. One of the biggest benefits that we have seen with augmented and virtual reality is when it comes to enabling people to truly understand the spatial and physical relationships between objects within a facility. Unless specially trained or naturally inclined, most people have a very difficult time truly understand 3D spatial relationships from what they see on a 2D screen. However, immersing someone within a true 3D environment using AR or VR enables them to easily see and correct spatial issues that may impact operations, safety, security, and so forth. Traditional design reviews consist of large group meetings watching a common 2D display, with a note-taker capturing group commentary. These are typically multi-day events, requiring many people to travel to a common location, even though an individual's contribution may be as little as a couple of hours in total over the several days. Also, individual comments are often difficult to attribute to any one reviewer, making it challenging to follow up should questions arise as to their interpretation. However, by assigning action items to individual reviewers and providing them with a way to review the design on their own schedule, asynchronously, not only is it much more time efficient, but commentary can be directly attributed to the reviewer who left it, facilitating easy follow-up should it be required. The pandemic highlighted a number of logistical challenges in common business practices, and design reviews were no exception. The requirement to bring together larger groups of people into a single room for multiple days, often from long distances away, just didn't work under pandemic conditions. However, watching someone else show you design elements through a video call significantly degrades an already flawed design review process. So enabling people to individually review design from wherever they may be located and whenever they have availability creates a new level of participation by reviewers that is not practical nor sometimes even possible under pandemic conditions in classical design review processes. It also saves tremendous amounts of time and money by providing and removing the need to travel for design reviews, even when pandemic conditions are no longer a consideration. In traditional design reviews, the group comments that are captured are reviewed at each new design release to ensure that they have been addressed. However, with significant design changes, it can be difficult to correlate the comments with corresponding design changes, particularly if individual attribution of the comment is not known. By integrating action items and comments directly into the design review system, tracking is automatic and easily attributable. This makes it easy to confirm that the appropriate design changes have been made, and therefore easy to gain sign-off from the appropriate parties. While AR and VR provide very good 3D visualization environments, the ability to read and particular type detailed text is less robust. Our testing has shown that the use of a companion device that people are already familiar with, such as a smartphone, linked to the AR device facilitates a much easier text interaction. This simplifies the design review process and results in more detailed and informative commentary. The final insight I want to share is that for a fully deployable solution, AR and VR are often not enough. Not everyone has access to such equipment in their location, and for design reviews, this can provide a barrier to engagement. By providing other means of access, such as a web portal, the interaction may not be as immersive as AR or VR, but it is easily available from anywhere. And there's good internet access, well, anywhere there's good internet access, of course. And it's vastly superior to watching someone else do a review through a video call. If you'd like to learn more about any of these or other projects we worked on, or to explore opportunities for us to support your own business needs, please feel free to reach out. Thank you again for your time, and we look forward to talking with you further.